Hey, welcome to another live Wells Tech training class. I am so happy you are here. Today we're going to be talking about GM truck ABS. How many times have you run into a slow roll activation on those things? We're going to have some tips today. I got Mike with me, and we're going to go over on the vehicle. We got some cool stuff to show you, so don't go away. Hang in there. But before we get started, yes, we have to talk about the t-shirt giveaway, and here it is. Here is your question. You will see when we go to the wiring diagram for the ABS, there will be like a little figure 8 there between two wires, okay? What does that little figure 8 mean? What does this mean right there? You answer that question correctly, you text it in to us, and you send me your mailing address and your t-shirt size, and I'll get a t-shirt out to you tomorrow. One of these cool Wells Tech t-shirts. And if you don't have one yet, by gosh, you should be the first one on your block with one. All right, before we get into it, let's bring Mike on in here. Here's Michael Becker.
Hey.
He's going to help me out with this. Cool stuff. We're going to be doing GM ABS.
Yeah.
How many times have they been a problem?
They've been a problem for a long
Forever.
time.
How many times you pull up and you're going 3 miles an hour and da, 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 da.
Yeah.
You know, she activates, right?
Yeah, right on dry pavement, whatever. It doesn't make a
Anywhere,
difference.
it don't matter,
Yeah.
right? So we're going to go through that today. We're going to see how it works,
Yep.
right? And we're going to figure out how to fix it,
Right.
right? All right, there you go. And it isn't always the fix you may think.
Right.
It isn't just replacing the hub, is it?
No, I mean,
Okay.
it would probably take care of the problem, but
Yeah,
sometimes
it would.
it's a little overkill.
Yeah, it would always take care of the problem, but
Yeah.
you don't always have to do that.
Right.
And it's always a good idea to know how the system functions.
Exactly.
And once you learn how this functions, you can learn how about a lot of things on a car function.
Exactly.
Right?
Yeah.
That's what's cool.
ABS sensors, like a lot of different sensors.
There are a lot of the same.
Yeah.
You know, how many different, a Hall effect's a Hall effect, right? Right? And this is an AC generating
Yep.
type sensor, and whether it's what? Crank sensor?
Crank, cam, whatever. They all kind of function the same
All
way.
work the same way.
Yeah.
Right. Okay. So let's, without further ado, let's take a look at that wiring diagram,
right.
and let's go through that just a little bit.
Sure.
And up in the upper left-hand corner there, we have, what is that? That is the power supply for our ABS system. Is that
Yeah,
correct?
for the ABS motor itself that's built inside of that EBCM module.
Yeah. So that what that's diagram is showing us is that we're running it off that fuse.
Yep.
And it's down into the ABS motor to activate that
Right.
type of thing. Okay, but what we're really concerned with is if you move over a little bit to the right, you see those two front wheels there.
Yep.
Right? And these are our front ABS sensors, our
Yep.
front ABS
Wheel
system.
speed sensors,
And
yep.
this vehicle only has front ABS, right?
Correct, yep.
Okay, so our ABS system is actually right here.
Exactly.
Okay, so if we look at that left front one, right, you can
Yep.
see there's a trigger wheel on the top, that geared looking thing up on the top.
Right.
And then there's a box that has the wiring in it like
Yep.
this.
Yeah,
Kind of
just
looks
like
like
that.
this right here. And when you see this display right there, that means that there's a winding there. There's a
Yep.
wind in a wire, right? And this usually means that there's a magnet here. Okay, so there's a magnet in there, and there's a wind in a wire.
Yep.
And then each one leads down to the computer.
Right, yeah. One side's a low reference to the computer, which we commonly would refer to a ground
Right.
inside the computer, and then the other one is actually going to be our signal.
Right, okay. So, but the signal coming out of there is going to be an AC signal, right?
Right, yep.
AC means up on top and below the zero line.
Right, so if we
we're
put it
going-
on the scope, we would see the sine wave up and down.
Right, okay. So, the way this works, you want to talk about how this works? How it actually generates?
Sure.
Why don't you do that?
Okay, so just like on a cam or crank sensor, something like that, you have your string of wire there, and that's actually one long piece of wire.
And that's a good point, and this wiring diagram right here is telling us really how
Right.
this thing works.
Yeah.
And it tells us that is just one long piece of wire.
Right.
That's all it is.
From pin, whatever that is that A2 at the computer?
I don't know, from the two pins.
Right. All the way through the tip of the sensor there and through the coil of wire,
Right.
and then back to the computer. It's all one piece of wire.
It's just one piece of wire.
So we would
That's all it
expect to see, when we're testing, we would expect to see an ohm reading on that. I
Exactly.
believe spec on this one is about 1,050 ohms.
We could kind of relate this to like a secondary or primary winding in a coil, right?
Very similar.
It's the same thing, right?
Yep.
It's just one long piece of wire, so you just take your ohm meter, stick it on each end of that wire, you should get a resistance reading.
Exactly.
And they're going to vary depending upon how much wire and the thickness of the wire and all that kind of stuff.
Right.
But you will get a resistance reading if you have a complete wire.
Exactly. Yep. So, and what's kind of interesting is you don't see a power feed on the circuit because an AC signal generator circuit creates its own power.
Ah.
It creates...
Magically.
Yeah, magic, all right. The magic of magnetic fields.
The magic of magnets.
So, like you talked about, there's a magnet inside the tip of that sensor.
Yes.
Everybody knows when a bearing fails or something on these, they collect all those metal particles at the end because there's a magnet inside there.
Right.
So that wheel there at the top, that toothed ring, that's part of the bearing. As that passes by that magnet, well, actually, before we pass by the magnet, we'll talk about the coil of wires. As it flows through there, it creates a magnetic field. So you pass that toothed wheel past the magnet.
Well, let's step back just a second. Okay.
Okay.
So let's take a look. We got a sensor here, actually. Okay, let's take a look at that. All right, and this one here, the outside, this is the bad one.
Yes.
And the outside here is broken off, but there is a magnet in here. You can see the magnet right there.
Yep.
I don't have anything magnetic. Oh, right here, right there. You can feel it. Okay, so we got a magnet right here, right? So we have a magnetic field in the rest position.
Right.
Okay, so let's take it from there.
So the magnetic field's in the rest position right now. We pass our tone ring or our tone wheel past that. So as the high spot of the ring passes, the magnetic field transfers over to that high spot on the tone ring and creates a high spot on our graph.
All right.
As that tone ring passes by the magnet and goes to the low spot on the tone ring, the magnetic field goes back into the coil of windings, or the coil of wire, and we get our low spot on our graph.
Yep, and that's where the magic happens. Okay.
Right.
So, and I don't know, honestly, I don't know if it's going to be high then or low then. I don't know. I don't know if when you put the piece of metal here, if that's going to be high or low voltage. It doesn't matter.
Right.
It's
We're just
all we
looking
know
for the
is
up and the
it's
down.
going to be a voltage output. Because what you did is you have a magnet here, and its magnetic field is resting. Okay,
Yes.
it's right around here. Okay, you can't see it, but it's there. All right, so when you take a piece of metal and you put it close to there, what's going to happen to that magnetic field is it's going to try to attract that magnet closer. So it's going to move that magnetic field a little bit, right, to try and drag that metal closer.
Right.
Right, so there's where the magic happens. When you take a magnetic field and you move it across a wire, whether it's a winding wire or just a piece of wire, when you move it across the wire, you get the electrons active.
Yep.
You get them to flow. And that is electricity.
And that creates our AC voltage.
Right. So then when it comes to the center, you no longer have a metal, ferrous piece of metal there. When it comes to the center, now the magnetic field goes back to its rest position, and it's moving back across those windings the other way.
Okay.
So you move it this way and that way. That way, that way. That's how you generate that electricity.
Okay.
All right?
Yeah.
Crank sensors, cam sensors, they all work the same way.
Exactly.
The beauty is if you know how this works, you know how they work.
Yeah.
All right? And they get tested the same way too.
Right. Yeah.
It's the same thing. It's that simple. Don't make it hard. It's
Right.
not hard. Okay? And it's just, you can't really see what's happening there, but if you got a mental image of what's going on, I hope that helped with your mental image, because that's what I always think when I look at this stuff, right?
Definitely cleared it up for me because
Well, good.
coming
Did
from
you see the lights come on?
yeah, exactly. Coming from in the repair facility type of work, I would always hook my meter up, do my ohm test, check my millivolt AC millivolt reading on here, and then I would know if my sensor was failed or not. I never really cared to look into how it exactly functions.
Yeah.
But when you understand that, it helps you to understand possibly what's going wrong. So if I had an intermittent problem or, say I had a bad tone ring or something, I would watch that graph on a scope and you could see on there, you would see it go up and down and then you might have a glitch in it or something like that. That by knowing how the system works would help me diagnose it a lot faster.
Or is there something stuck to that tone ring?
True.
Right?
Yeah.
Because a lot of times the tone ring, like if you, I've run into situations even with Hall effects where the car will sit for 2 years.
Okay.
Right? So all the time, this metal trigger wheel is sitting in that magnetic field that whole time. Right?
Okay.
So what happens is it becomes magnetic after a while.
That doesn't work very well, does it?
No. So when it turns magnetic, we ain't dragging no magnetic field anywhere.
Right.
Right? So you're going to get a dead spot when it comes around there. Or if it's a Hall effect and you stick a magnet in there, you aren't blocking anything. You're helping it. Right?
Right.
So all these weird things
that could
happen.
really mess with your head.
It could really mess with your head.
Yeah.
And that's exactly what you're talking about there. Like if this thing sat long enough and it was close enough to that trigger wheel, you get one spot that isn't working because it's magnetized, right? So you got to watch out for that stuff too. But you're exactly right. And that's why I always, if you know how this stuff works, repairing it and diagnosing it is easy.
Right.
First, you got to know how this stuff works. It takes all that mystery out. Open up the black box.
Right.
Right?
Yep.
And so, that's what we're here for. And that's what we're going to do today.
Okay.
And we're going to...
Actually, there was one more thing I wanted to talk about. When I was speaking with Dave, one of our engineers on this one, for ABS sensors, I was asking him about the amplitude or the height of the sine wave and how that correlates to the speed of the vehicle. Because the computer in here is actually measuring the distance between the ups and downs.
That's
the
correct.
Frequency.
Yep.
So it's measuring the frequency to determine wheel speed.
Right.
But I was asking him what affects, because an AC signal generator, the faster you move that wheel inside there, the more voltage you're going to get.
That's true.
So I was asking him how it correlated speed to the amplitude.
Right.
And he said it's a pretty much direct correlation.
Yep.
He said at about 50 revolutions of the wheel, you should expect to see about 300 to 450 millivolts.
Okay.
So
well,
if you
that's
spin
kind of a
that
cool
weel
spec.
up to
If you
2,000,
can count that. I don't know.
yeah, well, they're saying about 1 revolution per second, you should see about 350 millivolts.
Okay.
And then if you go up to 2,000 RPM of the wheel, you should expect to see over 12 volts of
And that's
AC.
that's what they're seeing in the lab, right?
Right.
Yeah. That's interesting.
So it's interesting how that amplitude will change depending on how fast you spin that wheel.
It is.
Which is really interesting for these GM trucks, because the main problem with the false activation is the air gap is becoming increased. There's a rust buildup, so your sensor mounts to the hub. Rust builds up underneath where it mounts, increases the air gap. That's why it only happens at low speeds.
Right.
Because the amplitude isn't high enough on the graph for the computer to see it.
And if you look, like we've talked about this in other classes where, the computer is not going to look at the 90-degree angle like on a digital signal coming up. And it's the same thing with this stuff. It's looking for a level.
Right.
It has to hit that level to say this wheel is turning. If you don't hit that level, whatever that may be, 0.1 volt, 0.01 volt, whatever the heck it is, if it don't hit that wheel is not turning. But I see that from the other wheel,
Right.
and that's turning, so that means we're moving, that means this wheel is skidding.
Yeah. Yep. And I think it also takes the transmission speed sensor into effect too.
Yes. Yep, it does. So. Yep. And the newer ones even get more sophisticated than that.
Yeah.
But which is cool. But you got to know this stuff too. And so, anyways, very cool. That's a very good point.
Yeah.
You know what I feel like doing? Getting over on a vehicle and
Should we
start
test something?
tearing. Yeah, let's start making something happen here.
Okay, let's do it.
All right, let's go.
All right, let's go. All right.
All right, here we are with our 2003 Chevy truck.
Yep.
Yes.
It's a 1500, and yeah, it's a 4.8. Doesn't really make a difference on on here. But
they're all tip them upside down. They're all the same.
yeah,
right?
exactly.
Okay. All right. Mike is actually one who went through the diagnostics and the repair of this. Let's start there. Let's explain what you did and go through those steps first.
Well, the customer had talked to me on this one and said that he was having false ABS activation, low speeds, parking lots, coming up to stop signs, leaving his driveway, that kind of thing.
You never heard about that on GM trucks before?
Never.
Never.
So, and he did mention too, the ABS light was not on. So that's interesting about these. The ABS light doesn't come on. So the truck actually thinks that the wheel's slipping.
Right.
So
it doesn't think there's a problem.
Right, exactly. So I went in and didn't pay to check for codes because the light wasn't on, so I didn't check for codes. I went out to Diagnostics right away and looked up some information on the system. Found out that our wheel bearing hub assemblies and our sensors are both very, very common for these trucks. And I had already kind of known that, but wanted to dig a little deeper.
Yep.
And I actually found a GM bulletin here that came out, and it talks about low speed activation, not setting a light.
And by the way, that's why we're here, by the way, because we have the time and we have the desire to dig a little bit deeper.
Yep.
And that way, you guys don't have to. You can keep working on the car.
Exactly, making money that way.
Yes.
So I went ahead and printed off our bulletin here, and it talks about how rust can build up on the outside of our hub here and get between the sensor and the hub and create a bigger air gap and make our sensor not work at low speeds.
It's amazing the difference that makes.
It is.
And we're going to show that to you today. It's pretty cool.
So I went ahead and got to the sensors, pulled them out, and we're going to show you a little trick here on how to get the sensors out where you're not breaking the tip of the sensor off.
Right.
But we got the sensors out, looked inside there, everything looked okay, put new sensors in, cleaned off our rust, and the truck is good to go now. It's working fine.
And that was the difference. You know, a lot of times, a lot of guys out there immediately go, okay, we got to change the hubs. That isn't necessarily true. Some of these can be replaced, and it isn't as hard as you may think it is. And it works just fine. You can save your customer some money, and you can actually make more money by actually doing the work to repair it.
Right.
You know.
Yeah, the hubs on this one were just fine. There was no play in the wheel bearings at all. They were quiet.
And that's the first place you want to go, right? You know, wiggle that. If you're wiggling the wheel and it's wiggling all over the place, game over. you need the hub. You need the sensor. We're done, right? But if that hub is good, I mean, there's no sense to replace it.
Right.
And so
let's just let's run down the test procedures I did.
Okay.
So first of all, I did an ohm check, but do we want to show taking the sensor out first?
Yeah, well,
Let's
we'll
do
just
that.
pull, while you're talking about that, I'll just...
Sure.
And this is set up just like it is on the vehicle. The reason why we're using this, we went over to our engineering department and got this because they use it in their demonstrations and testing. And the reason we got this is because it's really hard to see in here exactly what's going on. So we're going to do it out here.
Right.
Okay.
So we'll pull the bolt off, and here I'll show you guys the trick that I used. And this is what worked for me, and I don't know, this is what I'd recommend to do.
Right. Sure.
What you can do is you can get in here alongside where the bolt goes and get the screwdriver in between the shield and where it bolts down and twist the sensor.
Right.
And you'll actually twist it back and forth. And by working it back and forth, you'll actually be breaking the outer shield off that's around the tip of the sensor. You'll break that off, and then you'll be able to wiggle the sensor out by very slowly and patiently working it up.
Right, and get up underneath there with a couple screwdrivers and try to pull it up even.
And some penetrating oil
If you do break the whole sensor off in there, it's a lot harder to get it out.
It is.
It is, and so you kind of want to avoid that. And another thing I would suggest is, like if you have a customer comes in, he's got this problem, or if he comes out even out on a drive, get your PB blaster or whatever you're using for your penetrating oil, and try not to get it on the brake pads, but get down in there and just spray some on that and let it sit there for a week, you know, until he comes back for the repair, and it'll make a world of difference. It'll help a lot.
Yep. And then once you do get the sensor out, like we had gotten this one out where it left the cap or the plastic outer piece in there, you just pick that out with a pick or a screwdriver.
Right, it comes out real easy after that. Where it's going to hang up, here I'm going to pull this out of here real quick, is it's going to hang up on the O-ring right there. That's where it gets hung up. So once you break that outer shield off, you can pull the inside out, and then you can pick that out of there pretty easily.
Yeah.
So, and then once you get it out, look down in there, look for any metal bits, look for any metal bits on the end of the sensor.
Yeah, if that bearing's failing, you'll see it on the tip of that magnet.
Right, it'll show up. And if you do have metal shavings in there, again, game over. It's done. The bearing needs to be replaced. But if you don't see any evidence of that, and the bearing is tight, it's good.
All right, let's do some tests.
Okay.
All right, so we have our meter right now hooked up to the speed sensor.
Right, here I'll show you. Just a couple jumper wires and our meter. That's all it is.
So what I'm going to go ahead and do first is we'll do an ohm check first. This is what I always used to do, is just do an ohm check first, and I suppose I should have
plug it in, and you're going to be
leads in the meter.
You're not going to be on the amp side.
Nope, I'm going to doing things backwards here.
Right.
So when you're actually in the right side,
if you think you know how to do it standing on your head. Right.
Exactly. So you'll see we got 1,063 ohms, and that's the spec on this is 1,050 plus or minus 10%. 10%.
So you were right there. You know, it's checking out good. And right here you can see our meter is reading 1.063 k ohms.
Right.
Okay, and that K stands for 1,000. And whenever you see that on your meter, if you watched our prior broadcast, in your mind's eye, that decimal point becomes a comma.
Right.
Okay, and there's always 3 digits after a comma, so if that 9 was, or that 3 wasn't there at the end, we'd add a 0 and we'd have 1,060.
Right, and so I went ahead and ohm checked both sides. They were both in spec.
Yep.
So according to our GM bulletin here, the next step that you're going to do is actually measure the voltage AC that the sensor is actually generating.
Right.
And GM says the spec here is at 1 revolution per second. So you spin this 1 time around in a second. You should see greater than 350 millivolts AC.
Right. So 0.350, whatever you're reading there. And that's really cool. We actually found a spec for this, and that's the problem is, okay, how do you rate that speed?
Right.
Because the speed is going to affect amplitude. So you got to kind of keep it to that 1 second turn.
Right.
That's what we're going to do here.
Okay.
We're going to check my calculations of my arm here.
Sure. So,
Okay.
and that's a minimum spec, 350 millivolts minimum.
Right.
And so we'll go to AC on our meter. If you go to DC, you're not going to get any reading, or you'll get possibly even a negative reading.
And all I'm going to do is, I don't have the bolt in here, I'm just going to hold it down with my thumb.
All right,
That's
give
all
it a
we're
spin.
doing. Okay, we're going to go.
And you can see already we're well over 350 millivolts AC. This bearing and sensors in spec.
Right.
But when I did it on the truck and tested on the sensors that were on the truck, I was at about 100 to 180 millivolts AC, under spec. And that, which from reading through our GM bulletin here, means that our air gap is too far. The sensor's spaced away too far from its tone
Or
ring.
the magnet's weak, or
Exactly.
you got a wire that's broke.
Yep.
It could be a million different things. But yeah, you're not getting the output is what it means.
Right.
Yeah.
And I thought it was interesting that when we talked to the engineer, he had said that the amplitude increases with speed, like we talked about.
Yep.
So that's why these things would only false activate when it was low speed, because the amplitude wasn't high enough at that 5 miles an hour
That
or
is
whatever.
correct. And it's amazing how much these actually put out. What did you
Right.
get there on that? Didn't you have a spec on that it would?
Oh yeah, the maximum spec on these, which
Yeah.
is, I found really interesting, was 100 volts AC at
100
2,000
volts
RPM.
AC.
That's the
Holy
max
cow.
spec.
It makes you wonder why they don't harness this. But you know, in hybrids, if you
Yep.
watch our hybrid classes, that's what they're doing.
Right.
You know, and so that's energy that's just being wasted at this point.
Right.
Which is a big no-no these days.
Right. So why don't we now go ahead and show
Let's
them what
look
the
at it on
air
the
gap
scope.
does.
Yeah.
Yep.
Let's go to the scope.
So I'll go ahead, take our leads out of here and put them in
And
our
there is
scope.
definitely an advantage to using a scope, and we'll show you that here in
Right.
a minute. You can do it with your meter, don't get me wrong, but there is an advantage to using a
Yep.
scope.
So we'll go and look here. So we were at right now we're at a 5-second interval, so 0 to 5 seconds, and on a 5-volt scale. So 0 is right here, and we go up to 2.5 and down to 2.5.
Right.
And you want that 0 line in the middle because you're measuring AC current. You're looking for the waves.
On both sides of the 0 line.
Yep.
Okay, you ready?
Yep,
We'll
give
do
it a
that
s-
same spin again. I'll try to do it for 1 second per revolution.
Okay, we'll stop it right there. And if you look down here, our max voltage reading is 1.917 volts, and it's kind of hard to read.
Yeah, it is,
But-
but I can see it.
1.917 is the output that it's putting out right now.
Right.
So why don't we introduce a rust?
A
or-
variable. Okay, we have a
Exactly.
variable here. And what I have in my hand here is a feeler gauge. Okay, I'm sure you guys are all familiar with it. And the first one I'm going to use is the 10,000th thickness. Okay, so this is 10,000ths of an inch. And what I'm going to do is I'm going to slip it up underneath where the bolt goes, and I'm going to hold it again in that position, and
Just
then we're
like-
going to spin it.
Just like
and
the rust builds up.
Let's see if we have a difference, okay?
All right.
All right.
All right. You can tell it already looks different. The amplitude's not as high.
Right.
And right now our max spec is 318 millivolts AC.
Right,
So,
so
a
you can
huge
see
difference.
it just on 10,000ths of an inch, there's a
Right.
huge difference there. Okay, what I'm going to do now is I also have a 3,000ths thickness here, and I'm going to stick that in there. That's the thickness of an average human hair.
Right.
Okay, so it's not a lot. There isn't a lot of space here, and it slips in there pretty easily.
Okay.
All right, let's try that again. You ready?
Yep. Okay. And now our max spec is 591 millivolts AC. So
Look at that.
roughly a third of our original spec
Right.
with 3 thousandths. That's a huge difference.
Right, there's a huge difference there. So anytime, that just shows you how critical that air gap is
Right.
on these things. Not only on these wheel speed sensors, but on crank sensors, all that. Anytime you're using
Exactly, yeah.
the two-wire technology, you know, it's critical. And magnet size and all that stuff comes into effect. Wire, diameter,
Everything.
the whole thing. It's amazing what these engineers go through just to make a simple, what seems to be a simple part.
Right. So that's one of the more common failures on here. Oh, and I did forget to mention, when you install your new sensor, you'll get some grease with it.
Yep.
Put that on the tip of the sensor, and then also put that on the spot where it bolts down to try and
mounting
inhibit
area.
the rust.
Yeah.
Because that'll try and inhibit that rust buildup again.
Right, it'll
so-
just, it'll slow it down. It's not a cure, but it'll slow it down.
Right. Okay, so that's one problem. Let's go on to
Right.
the next one.
Another problem is metal shavings,
Right.
okay? And when you pull the sensor out, you see it, it's all full of metal shavings. When you see that, it's game over. It's time for a bearing. But why does that interfere with the amplitude or the output of this thing, which is interesting. So what we can do to simulate that is, again, I'm going to use my feeler gauge here. What I'm going to do is I'm just going to run that feeler gauge across here like this. Okay, so you can see that. And then you can see that we generate a voltage.
Right,
Right
yep.
there. Okay. So you can see every time I do that, I'm generating a voltage off of it. It doesn't look as clean and cute as turning this, but it does work. Okay,
Right.
so what I did is I went to the tool room, and they have drill presses there. And I went to the drill press, and I got a whole bunch of metal shavings. That's what this is. And I'm going to stick them on this magnet here.
I mean, you'd expect to see
Kind of
this-
spread them around a little bit, but pull a few of these off so I can get to the magnet. There we go.
when that bearing fails, you'll pull it out, and it'll look similar to that. Not
Yeah,
as big of chunks,
be
but
small, not as big of chunks because they get all ground up in there, but it's the same thing. It's the same effect. Okay, so now I'm going to take and hit this,
and our amplitude is a lot less now.
and we're doing the same thing as I was doing before, only we got these metal chunks on here.
Right.
Right. So what's happening with this is, remember we explained that the way that these work is the magnetic field has to move across these windings. If the magnetic field is stagnant, you're not going to generate any electricity.
Oh,
And so what's happening
I thought it
is,
was just magic that did it.
it's just magic. It is magic. All right. What's happening is when those metal bits get on there, it's containing that magnetic field. It's not allowing it to move. And even if you introduce another piece of metal there, these magnetic fields are already holding this in. They're not going to be attracted to that other other ferrous piece of metal. Okay, that's in the distance of the magnetic fields.
Okay.
Okay, so you're not going to get any movement across those windings. Without movement, there's no electricity.
Right.
Okay, so when you see this happening, that magnetic field is going back and forth across these windings very quickly. That's how that works.
Right. And that's why when we increase speed, it increases our amplitude.
That is correct. Yep.
All right. So that's another common failure. Everybody's seen bearings go bad on these, and
Yep.
that's why the sensors don't end up working then.
Right.
So
that's
let's
what
take
happens.
this one step further here.
Okay.
On these bearings, they're not as common, but on, say, mid-2000s Escape or something, everybody's seen where the tone rings crack on the, they're actually mounted to the CV shaft.
Or it can happen on one of these.
Sure.
It would be similar to what you're talking about, like if you got a whole bunch of metal flakes stuck in one of the grooves
Okay.
in between the metal triggers.
Sure.
Okay, so it'd be one big piece of metal is what it looks
It would look
like.
like a trigger point on a crank sensor or something like
Right.
that. And so the best way to look at that, and especially for intermittent problems, is get out your lab scope and kind of zoom in on the time. We're going to go from a 5-second interval down to a 200 millisecond interval. So right now our scope is reading 200 milliseconds across here.
Right.
And we can watch that pattern and look for any glitches or indiscrepancies in the pattern.
Let's take our own ones and see
All
what
right.
it looks like.
So you can see as he changes the speed, our amplitude will actually go up. You'll see it'll actually, oh, there we go.
Got it?
There we go. Perfect.
You're wearing me out here.
All right, I'll pause it right there.
Okay.
So if we had, say, a bad tone ring or something, you would expect to see a glitch or one here that just looks different.
Right. Yeah, you'll see a flat spot, you know, where
Yep.
there's no trigger, that kind of thing. And that's what happened is the magnetic fields didn't move.
Exactly.
And so you get that flat spot. And another thing I like to point out quick is, you know, the amplitude, as long as you cross the trigger point that the computer is looking for. Remember we talked about this before on scope patterns, that computers are always looking for a trigger point. Like let's say this is the 0 point right here, or right here would be easier. And then like our spec says, it has to generate at least 350 millivolts.
Right.
And I'm at this, it doesn't say that in there, but I'm gonna assume that's near the trigger point.
Right.
Okay,
That
let's say
makes
it's
sense.
300 millivolts. Okay, so the trigger point that it's looking for to make sure that wheel is turning is 300 millivolts. It's got to hit that point. Okay, that type of thing. That's what it's looking for, and then it's looking for it again when it drops below that voltage and negative 300. That's what it's looking for. Those 4 trigger points on that one sine wave. So
Cool.
there you go.
Perfect. So that's probably the three most common failures with wheel speed
Oh,
sensors
absolutely,
and that kind of thing.
absolutely.
And it's nice you're able to just replace the sensors on these and not have to charge a customer for those expensive bearings and
Right.
stuff if they're just fine. I mean,
Exactly. You know, why replace these bearings if they don't have to be? And
Right.
you can save. And like I said, instead of you know making the money on the parts that you're selling, you make the money on the labor that you're doing. It's the
Right.
same thing. You actually make more money by doing the repair.
Yep.
You know. So, anyways, there you go. We got any questions
we
or
got a
anything?
bunch
Okay.
of
Let me talk
comments.
about the question first.
Okay.
You saw that figure 8 thing. What that meant is that these wires are twisted together or shielded. They're shielded from RFI. And what happens then is instead of having one long piece of wire, that would be like a plane of metal, so to speak. And if you have any RFI running around the engine, let's say coming off the ignition wires or coils or whatever, and it'll affect a long plane much easier than it would just a short piece, and that's why they twist them. They also shield them with tin, and some of them will look like that too. I'll accept any one of these answers that talk about shielding or twisting wires, all that kind of stuff. Okay,
Perfect.
It's the same thing, and if you said that, you got the right thought. You're right there. That's exactly what you should be thinking.
Cool.
And so there you go. Bring up my
have-
email address if you would, please, Dave. And if you answered that question correctly, and if you'd like a Wells Tech t-shirt, a really cool one like this, send me an email with your shirt size and your mailing address, and we'll get them out to you tomorrow. We'd love you to have them. And by the way, when you get one, and you get some nice weather, hopefully we've got some nice weather coming pretty soon.
Hopefully.
You know, just go somewhere in your city and take a selfie of it, you know, showing us where you are, and send it to me, and we'll get it out on our website.
Okay.
So we'd appreciate that.
All right.
All right, we got
And
any
then,
questions?
but actually in an effort to try and keep everything within our time limit we want and try and keep things down, I'm going to answer Terry and John and Scott. I'll answer all your guys' questions in our invite video next week.
We got a lot of questions.
We did.
Oh, good.
So I'm going to go ahead and answer those. So look for that video to come up.
Is the grease normal dielectric grease? Terry, yes it is.
You're taking it away from me now. Come
Okay,
on,
I'm
man.
sorry.
No, next week, Friday, we'll do our invite video for our next class. So look for your answers in that video. So
Yep.
come check that out, and I'll get your questions answered.
Pretty close to regular dielectric grease. We'll let this guy explain the details. Okay.
Sure.
Anything else?
No, that covers
All
it.
right, great stuff. All right. Thank you for being there. Without you being there, we would not be here, and we'll see you again next time in the Wells Tech Garage.
See you
Take care,
then.
guys.